All right, good morning, eighth grade. Today we are going to use this website called DESMOS.com to actually graph some data, create a scatter plot, and make some predictions based on the line of best fit. And actually create the line of best fit, not by estimating and by hand, but actually using a function in here to do that. So I'll share with you this website and a class code for an activity to do on Desmos. But I figured to kind of look at the data that's most relevant in our lives today, which is the COVID-19 data that the entire world and country is looking at. So I wanted to plot the points and look at the data based on this data here. So you can see this graph tells us the total COVID-19 cases in the United States. Again, that means total cases. So that includes all the cases that are still active and the cases that are no longer active, but it just keeps a running total of every case that's happened. So as you can see, it is increasing here, and this is kind of what it looks like. And before we left school on the 13th of March, which was like, where is March 13th? 2,183 cases. We were talking about how the function itself, or the graph, was starting to look exponential, and it was growing really fast. And that's what gave you, you went from all the way here, 15 cases, and then right around here is where things grew very exponentially, and it wasn't a linear straight line, it had a curve to it. So here's the exponential growth. And then we did, I think social distancing has helped, along with other measures. And you can see here, around March 25th is where I kind of looked at it. It no longer curved. You could almost say that here you have that linear line. It is straight. It is a constant rate of change. The slope is definitely positive. We're still increasing in cases, but it's not this exponential growth that we had in this period of March. So that's a good thing. That's great news. And that's why they're saying that the trend is we're starting to flatten the curve, because eventually, at least the way this graph is set up, right now there is a positive slope, but eventually we want the slope, probably will continue, but we want it to kind of smooth out and go straight. And we eventually want to have no new cases, so the total will just kind of cap out, or very little new cases. So we want that slope to eventually get closer and closer to a slope of m equals 0. So anyways, like I said, my reference point was March 25th, and I shared with you this data. And so if you look here, this is the data that I'm having you look at. And it says days, since your x, your independent value is your days since March 25th. So at x equals 0, you are on March 25th because it is 0 days from March 25th. But on x equals 3, you're now on March 28th because you're 3 days from March 25th. So I put the data going up to x equals 17, which is April 11th. And I left some of the rest of this blank for you, so that way you could, when you do your Desmos activity and with your class code and everything, you're going to probably be able to have the data all the way up leading to Wednesday's data, which I believe is the 15th. So you'll be able to fill in 1, 2, 3, 4 cells based on the data that you're going to get from this graph here. Okay, so let's talk more about how you're going to use this data to put into Desmos to create your scatter plot, and then I'll teach you a really cool function on here that allows you to make the line of best fit. So here goes. So what you're going to do, right, and you can kind of see I already did it already, you're going to highlight the data, just the numbers. You don't have to worry about everything else. So I'm going from 0 to 17. So that's 18, including the 0, that's 18 different data points. So just so I make sure you do this right, because this is my second time making the video. I messed up the first time. You have to press Command C, okay? So that will copy it. And then what you do here is you go into DESMOS and you do Command V. So these are, when we're referencing this, I'm going to call these your fields in your graphing calculator. So in your first field, the first box, you're going to paste Command V all the data. And it kind of does it nicely automatically for you, all the 18 scatter plot points on your graph. And it's really nice because it automatically changes your X and Y axis to match your data. So you can see here, like right here at this point, at day 17, since March 25th, we're at 532,879 total cases of COVID-19. So the next thing you're going to do when you create yours is you're going to connect the dots. I think it's a cool function you can do. So they call it a long click. So you're going to go on this area here. You're going to take your cursor, you're going to press and hold your cursor, your click, and then that's going to give you these functions. And so what you're going to do is you're going to go and change it to, right now it's just points. You can just highlight that here, and it'll connect the dots, and say you don't like green and you want to make it red, so it pops a little bit. You could do it like that. Okay, so that's the next step I wanted you to do. So you can see it's definitely a positive slope, but it's not a perfectly straight linear line because it's data. Every day things don't increase the number of cases exactly the same. So we want to get a line of best fit, and instead of doing it by hand, a lot of graphing calculators have functions where you can actually ask the graphing calculator to do the mathematical line of best fit. So what you're going to do here in the second field is you're going to type this. So you're going to go y1, so it's going to take all your y values, and then right next to the number 1, to the left of your number 1, there's that little, we talked about it when it was similar congruent. It's like the symbol for similar. So it's like approximately. So it'll give you a line of best fit. There's a little squiggly line. So you have to press Shift and this button. So again, hopefully, let me see if I can zoom in. It's that squiggly line you need there. So that it's going to give you the line of best fit. It's telling the computer to give you a line of best fit. So we know the format is mx plus b. So you're going to write m. It's going to look at the slope. And then you're going to put x1 because you want to look at these x1 coordinates here. And then you're going to tell it to do plus the y-intercept. So you're going to go plus b. Aha. So now you can see in my graph, a line of best fit was created. It looks a little weird in black, so I'm going to make it stand out a little bit. Possibly, can I change it? Maybe. Yeah, if you hold the click again, if you long click it, I'll change it to blue, for example. Maybe purple. Sure. Okay. So if you see here, so now you have your line of best fit. This is and kind of like we talked about in some of the parts of the lesson we did already. You have your line of best fit. When you do it by hand, you want to have some points below, some points above the line, but you will need a line that fits this pretty decently. So let's look more about what it's telling you here. So if you look in here, this is pretty cool here. It's giving you the rate of change, the slope. So according to this data set, the slope is 28,000 roughly, 28,006.3 to be exact. So every day in this data point, they're trending or predicting that it will increase by 28,000 cases. Again, this is just kind of prediction based on the data that we put in, and it's saying that it started at 39,000. Of course, and the actual data we started at 68,000. But again, it's just it's just modeling and taking the data and making an overall picture of this. So what we're going to do here, and then I'll talk to you a little bit about this. But this R value basically tells you how correlated or how, like we talked about, strong correlation or weak correlation, positive or negative. So the closer this number is to 1 or -1, then the closer there is a correlation. So if you look, it's pretty darn close. The R value is 0.9955, and that's because if you look, it's pretty correlated. It's a positive correlation, and the dots are pretty darn close to a straight line, but it's not a perfectly tight straight line. It's not perfectly linear. That's why we have this purple line of best fit. So the next thing we're going to do is we're going to write this down here to the nearest tenth. Our M value, our slope is 28,006.3, and our B value is 39,266.6. So now let's start making some predictions here, okay? So what I'm going to have you do next is use your line of best fit equation to predict the total number of cases for Monday, this coming Monday, for 2020. So the line of best fit equation, let's write this down here, is going to be y equals 28,006.3 x, all right, and then plus b, but my b value is 392,000. 392. Oh no, sorry, not 392,000. 39,266.6. Okay, so we need to now look at when is in our data the date for April 20th. So if you go over here, right, I kind of extended the numbers here. You could see it. So April 20th falls on x equals 26. So x equals 26, that means April 20th is 26 days from March 25th, which is where our data started. So what I'm going to do here is I'm going to go to this, right? I'm going to put, again, this is just a document. I'm going to do the math on my calculator. I'm going to let x equal, just make sure I get it right here. It was, what did I just say? 26. So I'm going to put x equals 26 here. Okay. So now let me just copy this here, put the function here. But now I'm going to put, I'm going to let x equal 26 here. So I'm going to substitute that in. I will, let's see here. So again, I'm replacing this here. Let's see, I'll even change the color to red, so you know I am doing this part here. So according to this model, this line of best fit, now all I have to do is multiply these two numbers and add the 39,000 and change. That was my B value, my starting point. So just give me a second to do this in my calculator. So 28,006.3 times 26 plus 39,266.6 equals. Okay, so according to this line of best fit, when you do all that, you get y. That's y now stands for the total number of cases is 767,000 and then 430. So 430.4. So obviously you can't have 0.4 of a case, so maybe you just round it to that number. Cases on April Patriots Day, Monday, April 20th, 2020. So again, this is just a prediction. And this data, this line of best fit, really, it's already missing some of the, we already have more data, because again, if you think about it, our data just stopped at the 11th, this past Saturday. Technically, I could have went all the way up to, I think today's the 14th. could have added 3 more numbers. Well, by the time you do this, you'll be able to add 4 more numbers. So just to kind of show you, if this is our prediction, 767,000, based on this line of best fit, pretty cool here too. If I go out here and let's see, we did, what was it, x equals 26. So you go here, you click on the graph, 26, this is, and I don't know if it'll let me go exactly at 20. Oh, there it is. 26, there's the number I just came up with by multiplying and adding my b value. So it's going to predict that. So if you actually look at the data, though, is that even reasonable? I don't know. I think, like they're saying, we're trending downwards. We're starting to flatten the curve. So I don't even think that's a reasonable number, because I think the number you're going to get is going to be lower because you're going to have more data points in your set. But if you think about it here, you can even see the flattening a little bit. It's kind of wanting to curve. On April 13th, that's 587,000, or round that up to 586,000, round it up to 587. So if you take 587, right, and then you find the difference between 587 and the predicted amount, round that to 4767. It's about 180 cases, 180,000 cases they think will happen between in this spot from here to here, 180 cases. So if you think about that, hopefully I'm doing this right. That's 1, 2, 3, 4, 5, and so on. So if you think about it, that's 5, and if you go down, sorry, let me just move down there. I was trying to show myself counting. Yeah, so if you think about it, 1, 2, 3, 4, 5, 6, 7, 8, 9 days. That's kind of cool. So 9 days, cool in the fact that the numbers work. So they're saying in 9 days we'll get 180,000 more cases. So that rate of change, right? If you think about it here, and you take 180 and you divide by 9, that's a pretty even number here. So 180 divided by 9 equals 20,000 cases per day. So that's what they think will happen according to our trend line, that we'll get 20,000 cases per day. And again, if you kind of look at it here, right, I don't know, like if you're at, according to our trend line, if you're at day 22 roughly, you're at 656,000, and day 23, yeah, it goes up a little bit, yeah, day 23, 56 to 89, 56 to 89, it's a little bit more than 20 there. So we'll see how that data ends up working out. So again, in the assignment I'm going to share with you, you're going to fill in the rest of this data, all these extra spaces, based on the most current data from here, which is going to be, by the time you get this, you'll have more data to work off of. And you're going to try to follow the same steps I did on this DESMOS application, where you're going to, or website, where you're going to paste the data. Sorry, I'm just zooming all the way out. There we are. You're going to paste the data in there. You're going to connect the dots by hold clicking here. And then the part that's going to give you the line of best fit is when you type in this part, and that will give you your slope. That will give you your y-intercept. So then you can write your equation here. And then once you have your equation, you can make the prediction, and you can use x equals 26, because I'm probably going to make it for April 20th again. And then maybe I'll add a different date in there to see if you can make a prediction further down the line. So I hope this video showed you a little bit about how scatter plots and line of best fit can be used in our world today with everything going on, and that you're able to complete this assignment on your own with your own DESMOS graph. Have a good day.